Hello everyone, how's it going? So today we are looking into speech synthesis, which is nothing but taking a text and converting it into a speech sample. So it's nothing but speech generation, speech synthesis, whatever you want to call it. So to give a better example of it, the Amazon Alexa or even the Google Home, these are all AI chatbots or virtual communication devices that we are using day to day, and these devices are using models like these to generate and create their speech profiles. So especially this one over here, Tacotron 2, this was developed by Google for the sole purpose of the Google Home project, where we nowadays we are communicating with it, and it uses this Tacotron in the back end in order for it to generate those speech modules for them. So we'll see how we can develop this. I found this Google Colab link. It's from the NVIDIA deep learning examples, and I found this Colab link. It has a very nice implementation. The other ones I found they're a bit complicated, and it goes over the training aspect, which I mean, for now, for an introductory reason, I don't think we need to go into that. But this comes off the shelf and it's ready to use, and we can see how the Tacotron runs. So if you're interested, I'll put the link in the description for the NVIDIA Tacotron library. So Tacotron 2 is, part of Google, but NVIDIA has shown up how they can implement it on their system, and this is the repository. This is the paper which is from the Google regarding the Tacotron 2. So this is where they describe how they developed the algorithm, and I'll show you how this is running. So the basic concept is it has a two-part system. One is you're given a text, and that text is converted into a MEL spectrogram. So if you see over here, you can see this graph, and this is nothing but the speech sample of how we speak, the audio sample or the wavegram of how we humans sound when we are talking about a particular text. So a particular word sound has this type of wave. A different type of word has a different type of wave. So this is MEL spectrogram, gives out a full wave diagram of how a speech text comes out to be. And then there is a second part which uses this MEL spectrogram to convert and utilize that for its own speech synthesis. So first step is to use a text and convert that into a MEL spectrogram, basically how a text would sound if someone were to speak, and then using that MEL spectrogram to generate its own voice based on the sample that it is already trained on. So to go into more detail, what we're doing is the first step is to go into runtime and make sure you're running on the GPU right here, and press save, and we start running this. So in this particular step, it will give you this error, go ahead and run anyway, so that's nothing to worry about. So the first step is to load the model. Now this model over here, it's already pre-trained, so we don't need to train. That's one of the reasons that I used this particular Colab file. It's already trained, and it's part of the deep learning, NVIDIA deep learning library, and it says that Unicode is not detected. For that purpose, I believe what we need to do is pip, we could do it this way, pip install Unicode. So this thing seems to be missing, and if we do Unicode, let's see, I think we should put that before this. So let's take care of here, and we run this. So let's see if that solves our problem. So we are basically loading the models that has already been trained by NVIDIA on the Tacotron, and they have this LJ speech dataset, and it's a free dataset. It's being published by the LibraryVox project. It's an audiobook, free audiobook library, and they have quite a bit of content over there. And they used that dataset from there It's a big data set, and this data set has corresponding speech and words. So it gives out how a word, it has the text and the corresponding audio clip around it. So it's a very, very comprehensive information which is being used, and this particular library, this particular model has been trained on that. So I guess that solved the problem. So we just added the pip install unit decode. That's all from us. Everything else is already part of NVIDIA's code. So with that, we were able to solve this problem. Now coming back to the next step, we're downloading these speech libraries. These are all speech and wave, the sound libraries. So we just need that, and we press the play button. We should be done with it. So it looks like everything is already installed. So I guess we don't even need this. Then the next step is to wave file. Now this is using all the, now it will start using the machine learning libraries to extract the models that were present and then use it. So now the next step is to call the Tacotron inference from which was already trained, and then use that network to generate our own model. So this is nothing but the convolution network on which the Tacotron was already set up. So we're just calling and setting up that network. So if you see all this thing, this is nothing but this particular diagram right here. It is extracting all this information and it's creating that network for us, so that now when you pass on the text or the speech sample, it will go through these layers and keep it ready for them. So it's just setting up the model. And once we do that, the next step is to call the wave glow. Wave glow is, I'm not sure if you have heard about WaveNet. WaveNet was what Google had created for generating speech samples, and wave glow is NVIDIA's version of WaveNet. So they took some good features of WaveNet and another library, another speech synthesis library, and they combined that to create a faster and more efficient speech synthesis library called WaveGlow. And NVIDIA has open sourced this one, and we're just using that right here to call our WaveGlow so that we can convert those MEL spectrogram into speech. It might be a little confusing, but if you go back to this image and understand what's going on. So the first step is when you're converting this text, you're sending out this text. The text is it's converted into, it's broken down and understand every character or every word in that sentence is then understood, and correspondingly that particular MEL spectrogram is generated. So it's whatever text you have, it is converting it into, and it's breaking it down, and then using a bidirectional LSTM, it is creating that MEL spectrogram for us, which goes into this whole process. And this MEL spectrogram is created, and with that it's using the samples which is already trained to generate the audio sample for us. So if this is already pre-trained on the LJ speech data set, but if we were to train our own, for that purpose you can go into this Tacotron library, and it shows how you can train your own data set. But to be honest, I looked into quite a bit of places, and it's not easy to set up your own data set. Imagine you need to have hours and hours of speech sample, but not just speech sample, you also need to have the corresponding text that represents, because you need to provide both. You need to provide the text and the corresponding voice sample, so the model understands how the text is supposed to be sound. So with that, I think we were able to set up the WaveGlow as well. All the WaveGlow is set up. The next step is just, now everything is done, ready. We just call the model and generate the text for us. So here it says it's using this text, hello world, I missed you. So instead of that, we'll put hello YouTube, I missed you. So let's go ahead and play. And we are using this text, and we are asking this model to generate that audio for us. So it's called sequence. Now this is using all that WaveGlow inference. We are using all that WaveGlow inference and then creating that audio wave for us. So with that, we're done. Now this is creating that audio wave file for us. This audio numpy is where it's what which has that's where the audio wave is present, and we're just saving it into audio.wave. It will be stored here in this folder, and with this file we can play right here. So now we can play this in the browser. We just push the play button.
I missed D.
Let me see if I can bring the mic closer to the speaker. So
Hello YouTube, I missed D.
So hello YouTube, it says missed you. It's not able to pronounce things properly, but let's see if we can have a different type of text. So let's try this text and see what it can do for us. Next step, we combine here and we combine here. Let's see.
Hello sir, what can I do for you?
What can I do for you? Okay, so that shows that it's working, and I'll put the link to this collab link right here in the description, so you guys can try it out yourself. And if you need this original source, it's present in this NVIDIA Tacotron library right here. So with that, I come to the conclusion of this video. If it's something that is helping you, and this check out the channel and see what kind of projects come up here. And if it's something that is interesting to you and useful to you, come along, join our journey in this where we learn and try to grow our skills. And with that, we come to the conclusion. You guys take care, stay safe, bye-bye.